Okay, class, today we're going to be doing a really cool experiment. It is called Marvelous Milk. And Marvelous Milk is where we are going to put milk inside of a shallow dish, put drops of food coloring, and then a drop of dish detergent on top of that. And we're just going to see what happens, and then we're going to talk about it. So, I have some materials in front of you. You should have two different colors of food coloring. You should have a shallow dish, and this is basically just a plastic plate that's about 1.5 inches, 2 inches thick. You should have 2 cotton swabs and some Dawn dish detergent and some milk. And you will also have your student data sheet, which we're going to use to follow along and kind of make our predictions and show what we know by the end of the experiment and what it has taught us. So let's go ahead and get started. So first things first, I want you to make a prediction on your student data sheet that's in front of you, and then give me a thumbs up when you're finished making your predictions. Tell me what you think will happen. Use the guiding questions on the sheet to make your predictions. And I'll just give you a second to do that. Okay, now that everyone has a thumbs up and they've made their predictions, would anyone like to raise their hand and share their prediction with us? Okay, great. So those are all very great predictions on what you think might happen. And so now let's just do the experiment and see what happens and see what we can find out. So first thing, I want the first partner to take your shallow dish and get your milk and let it pour. Make sure our plate's clean. Pour our milk inside our shallow dish. Okay. I want the second partner to take our food coloring, and I want you to do 2 dots of one color and 2 dots of the other color. And I want you to do it centralized to the center of your dish with the milk. And I want it to not be so close that it's immediately touching each other when you drop it in there, but just close to the center, almost making a square, 4 points of a square. So I'm going to go ahead and open up our food coloring, and I'm going to show you what we're going to do here. Alrighty. Okay, so we're going to do the blue first. I'm going to do my blue first. I'm going to do one just right here and one right here. Awesome. Then we'll take my red. I'm going to do one here and one here. Oops. That's okay. It's still going to work very well together. Okay. So that is the first thing that we do. And so the third partner will get to do the next part. So we're going to take our Dawn dish detergent. And we're going to open that up. Take our cotton swab. And I'm just going to pour a little bit of Dawn dish detergent on that. Alright. Awesome. And so you got your Dawn dish detergent on the tip of your cotton swab. And so let's just see what happens. Let's just take our cotton swab and put it in the very middle and just touch the milk. Wow. Amazing. I want you to observe what happened when you did that. And now I actually want the other partner to have the same experience. So let's take our other cotton swab that's clean, put a little dish detergent on it. And let's find, we'll do this one in like a corner close to the edge of where some food coloring is. So the second partner should get the full experience as well. So I'm just going to do mine right here. It doesn't really matter where you do it. It's happening here too. So I wonder how this is happening. Okay. I want you to observe what you see happening in our experiment we got going on here. I want someone to raise their hand and tell me why do you think this happened? Why do you think that when we touched the milk with the food coloring, with the soap, it dispersed the way it did? Those are very good observations on why you think that happened. I want you to fill in your findings portion of your student data sheet and just think about what do you think happened now that you have observed what would happen. Now just give me a minute to do that and give me a thumbs up when you're ready. Okay, awesome. So let's move on. Basically, at this point, we've finished our experiment. It's pretty cool. I'm going to put my tops back on my food coloring. But I want to discuss kind of our topic for the day. Why did I do this experiment, and why is it important that we learn about this? So I'm just going to talk and discuss about what was actually happening scientifically. So when you think about milk, milk is primarily made up of water, and water has a very high surface tension. And we know this because water can bead up very easily compared to like rubbing alcohol, which is also a liquid, but it doesn't bead up very easily. It has a low surface tension. Water, just like milk, has a high surface tension. But milk also is not made up just water. It also has fats, proteins, sugars, vitamins, and minerals. And so if I would have just taken the cotton swab and used the clean end and just touched the milk with the clean end, nothing dramatic would have happened like it did in our experiment. That is because cotton is actually an absorbent, and so all I would have created would be like a current or a ripple in the milk. But in this experiment, the high surface tension of the milk supports the dye molecules on the surface. So now we're talking about our food coloring. So our milk has a high surface tension. We put the food coloring on top of the milk, and the food coloring, it spreads out just a little bit, but it never mixes with our milk. That's because the food coloring is less dense than the milk, so it's going to float on top of the milk. But also because the high surface tension of the milk is supporting the dye molecules, and it keeps the dye relatively centralized, so it's not mixing and spreading a whole lot. Also, comparative to our food coloring, we have our soap, and the soap is kind of the special trick in our experiment. So the soap is called a surfactant. A surfactant is a surface active agent, and that is a lot. But basically, you may hear that in like cleaning commercials. Basically, how this is relevant to you is because soap, we use it to clean our dishes off grease or dirt or anything like that. And it's basically doing the same thing here. What's special about soap is able to reduce the surface tension of a liquid. And that's why we use it to clean things. And so when we do the drop of the liquid dish soap added to the milk, the surface tension of the milk is actually reduced. And as this occurs, the fat and the protein particles in the milk can move more freely and easily. And the soap is interacting with the fat and protein particles in the milk, causing the particles to move around. So the soap is interacting with those fat and protein particles from the milk, which causes the milk to disperse, which causes the food coloring to disperse as well. And that's how we saw that with the dye swirling around in the milk once that we applied that soap there. Eventually equilibrium is reached, and you can see that where our colors in our milk has stayed still and stopped moving. And so it only does it for just a very short period of time. So now students, I just want you to fill out the rest of your student data sheet and draw a label of a picture of what you saw happen in the experiment, and now what you know scientifically that actually did happen. And you can use symbols such as arrows or plus or minus, and then words, and you can even do a transition picture, however you choose. I would just like for you to represent how you know scientifically what happened in our experiment today and what affected that, specifically with surface tension, since that was the theme of our day.